Alright, so I wanted to go through this first practice test and just kind of make sure you get some solutions. So we have a mass on a spring and has a vibrational period of 5 seconds, and we want to know the spring constant of the spring. So to do that, let's be really clear. The 5 seconds is the period of vibration. That's the amount of time it takes for one vibration to happen. The 2 kilograms is the mass. When we're dealing with a mass on a spring, the formula for the vibrational period is given in the formula sheet as T equals 2 pi m over k. So what we're going to do is we're just going to simply substitute our numbers in here. So we'll have 5 equals 2 pi square root of 2 over k. Now, most people set this part up right, but what I want to do is kind of walk you through how you should put this in your calculator. So I would recommend starting by dividing both sides by 2 pi. And notice that I use parentheses. You should do that on your calculator as well. So that'll cancel this. And then the next step is when I actually put that in my calculator, what I'll end up getting is, again, putting it in parentheses, 0.796 equals the square root of 2 over k. And then what I'm going to do is now I will square both sides. Whoops. So 5 divided by 2 pi, and then I'll square that. So that's going to give me 0.633. And that's going to equal 2 over k. And now what I'm going to do is I'm going to multiply both sides by k. And so I'm going to get k equals, when I end up solving, about 3.15 or 3.2 newtons per meter. And now in the previous problem we asked what mass would give us twice the period. So let's be really clear. We're going to say that now we have a period of 10 seconds. And so that 10 seconds is going to equal 2 pi. And it's our mass that's unknown. And k equals 3.15 or 3.2. So let's begin by dividing by 2 pi on both sides. Again, I'm going to use the parentheses. That cancels here. So then I'm going to end up getting 10 divided by 2 pi equals m over 3.15. I'm going to multiply both sides by 3.15. That'll cancel here. And sorry, that's a pi right there. So when I actually simplify all of this, you're going to get a mass approximately equal to 8 kilograms. I think people got answers like 7.91 or 8.04, but it's around 8 kilograms. Now for number 3, it says we're going to double the amplitude of the oscillation and we want to know what happens to the period. Well, this is actually a trick question. It turns out that the amplitude has nothing to do with the period. So the answer, in fact, is nothing. All right, now for number 4, we want to know how long does a pendulum need to be to have a period of 5 seconds? So now we moved on to pendulum problems. The period of a pendulum is given by the following formula. T equals 2 pi L divided by G. And let's go ahead and plug in some numbers. So we want a 5-second period, so 5 equals 2 pi square root of the unknown L divided by 10. And sorry, I'm going to write this L a little bit better here. So now let's divide both sides by 2 pi. That'll cancel. And so now when I take 5 divided by 2 pi, that's going to give us 0.796 again. equals the square root of L over 10. We're going to square both sides. That's going to give us 0.633. Sorry, 633 equals L over 10. We'll multiply both sides by 10. That'll cancel here. And so we're going to get L is 6.33 meters. All right, now we're going to change this up a little bit. We're going to move the pendulum to a new planet. We'll keep the length of the pendulum equal to 6.33. And now we want to know the gravitational strength on this new planet if the period is 10 seconds. So we're going to have here 10 equals 2 times pi. And we'll put L here as the 6.33. And it's actually our G that is unknown. So once again, let's divide both sides by 2 pi. That'll cancel here. And kind of continuing with this algebra, it's going to give us 1.59. Equals the square root of 6.33 divided by G. Now let's square both sides. So when we actually square this little result here, that's going to give me about 2.53. So 2.53 equals 6.33 divided by G. So all I did here is I squared this side, and I squared this side. And now we're going to multiply both sides by G, and that'll cancel. And so G is going to end up being 6.33 divided by 2.53 here. That's going to give us a G value of about 2.5, roughly speaking, meters per second squared when I round. If we double the mass on the pendulum, well, if you look at the pendulum formula, there's no m anywhere in the formula. So what that really means in real life is that nothing happens to the period if we change the mass. All right, so that's page 1 of the practice test. We'll take a look at page 2 in the next video.